The last things that we're going to take a look at in this chapter about the heart is how exactly the output of the heart is regulated. And before we can look at what changes the output of the heart, first we need to define a whole bunch of words. When we're looking at how much the heart is pumping, we use a term called cardiac output. So cardiac output is just how much blood the heart is pumping. Specifically, there's a mathematical formula for cardiac output, and we abbreviate it as CO. It is equal to heart rate times something called stroke volume. The units for heart rate are beats per minute, and the unit for stroke volume is mils per beat. And so if we do a little chemistry, stoichiometry here, we can cross out beats and beats, and so we can see that our units for cardiac output are going to be milliliters per minute. Heart rate is the easy part of cardiac output to calculate, right? You just feel somebody's pulse, feel how many times their heart is beating in a minute. Stroke volume is a little bit trickier to determine. Here is how we determine stroke volume. It's again going to be a mathematical equation. So stroke volume is going to equal end diastolic volume minus end systolic volume. What in the world are all of those letters doing? Let me tell you about it. So EDV, which is end diastolic volume, is the amount of blood in each ventricle at the end of diastole, so right before systole when that ventricle contracts. And systolic volume, ESV, is how much blood is left in each ventricle at the end of systole. Let's take a look at an example of what this looks like. Imagine that this syringe full of blood models a ventricle. And so in the syringe, we can fill it with blood, and then we can push the blood out of it. And so as we fill the syringe, that's diastole, because during diastole is when liquid can be pumped into the ventricles. When we eject the syringe, that is contraction, so that is systole. So imagine that we have filled this syringe, and so right now we have completed diastole. So the volume of fluid that's in our syringe right now, this is end diastolic volume. This is how much blood is in the ventricle before the ventricle contracts. In our example, this is going to be 100 milliliters of fluid, is our end diastolic volume. Now, this syringe has undergone systole, so the syringe has been plunged. So in our model, it would be the ventricle contracting. And so now what we see, what's still left in the syringe, this is end systolic volume. Here's the blood that got pumped out. Here's the blood that still remains in the ventricle after it's been contracted. In this example, our end systolic volume is going to be 30 milliliters. In order to calculate our stroke volume over here, how much blood came out, we take our end diastolic volume, that was 100 mils, subtract our end systolic volume, which was 30 mils. That gives us 70 milliliters for our stroke volume. Remember our first equation, that cardiac output equals heart rate times stroke volume? Well, let's imagine that we have got a heart rate of 60 beats per minute and we had a stroke volume of 70 mils per beat. That means our cardiac output equals 4,200 mils per minute. One other equation I want you to be able to work with is something called ejection fraction. And what ejection fraction looks at is how much of the blood that started in the ventricle got pumped out. The formula for this is relatively intuitive. So in our example, we started with 100 mils of blood and 70 mils got pumped out. So it looks like 70% of the blood was pumped out, and that's the case. If you want to learn the official equation, it is stroke volume divided by end diastolic volume times 100. So in our case, our stroke volume was 70, our end diastolic volume was 100, and then we multiply that by 100 because we're looking at a percent to give us 70. So ejection fraction just looks at how much of the blood that started in that ventricle gets pumped out, and it can be calculated just knowing stroke volume and end diastolic volume. So what is normal cardiac output? Because obviously the next thing we're going to do is look at how we can change it, how the body makes it go up or down under different circumstances. So normal heart rate hangs out at about 70 beats per minute, and normal stroke volume hangs out at about 70 mils per beat. And so we know that cardiac output equals heart rate times stroke volume. So if we round up just a little bit, we get about 5,000 mils per minute as our typical cardiac output. Now, there's also kind of normal limits of variability. So heart rate can increase by up to 250%. And stroke volume can increase up to 100%. So 250%, 70 times 2.5, that would take us upwards of 200 beats per minute. And if we doubled our stroke volume, if we increased that by 100%, that could get up to about 140 mils per beat. And so those are kind of the normal ranges that we see for cardiac output. In our next videos, we're going to look at what determines heart rate, other than just the normal rate of the SA node, as well as how stroke volume can change in response to different circumstances. See you there.